We all know that large language models or LLMs are quite powerful. Now, just imagine to combine this power with the power of robots, and you have this new large language model called as PaLM-E. Danny Dries and their colleague at Google and Technische Universität Berlin have proposed PaLM-E. PaLM-E is a large multimodal model designed to help control robots. PaLM-E takes a text command and in executing the command uses sensor data from a robot to resolve it into a series of low-level subcommands. Then a separate system converts these low-level commands into robotic control signals, and the name E or the character E in this name PaLM-E is for embodied, which is basically on the back of Google's large language model PaLM. Now, on your screen, you can see the abstract of the paper, and if you want to read the whole paper, you can click on this PDF on the right, and it will take you the whole paper. Let me show you the GitHub repo of this PaLM-E, which is also quite exciting. So the way this PaLM-E works is very interesting. PaLM-E comprises of a pre-trained PaLM large language model, as I mentioned earlier, and also encoders that embed non-text inputs. And there are two things to it. First, a pre-trained vision transformer to embed images, and secondly, a vanilla neural network to embed robot sensor data that describe the pose, size, and color of objects in its view. In addition, the system relies on a motion controller that translates words into robotic control signals. In this case, a pre-trained RT1 given a high-level command such as, for example, I spilled my drink, can you bring something to clean it up? Plus images or sensor data from the robot, and then PaLM-E evaluates the robot situation and generates lower-level instructions. Let me show you the example from the video from this side. So this is full to speed. Let me go up a little. Sorry, there you go. So you can see that this is about bring me the rice chips from the drawer. And now robot is using all the sensor visionary data, and then other things are also being exposed to it. And there you go. Robot was able to pick the rice packet from here. And then it is doing it again and again. And if I scroll down, you can see here, um, this is another example of this as how to sort the blocks by color into corners, which robot is using vision, and also the instructions from large language models. There you go, it is more with more clarity. So the way it is working is, as I already mentioned, that there are two things: pre-trained vision transformer to embed images, and then a vanilla neural network to embed robot sensor data that describe the pose, size, and color. So the authors have trained this PaLM system for visual reasoning, which what it means is fine-tuning the language model and weight and training the vanilla neural network from scratch. They have used 12 data sets in this one. And if I click here, goes in and that keeps running. Let me show you another example. Maybe I'll just, okay, it's not enabled yet. The text tray, let's go up. Okay, while it runs, I'll try to explain how they have trained it. So as I mentioned earlier, they have used 12 datasets mostly for visual question answering and image captioning. They also use three datasets designed for training robots to manipulate objects such as task and motion planning, in which each example includes a text instruction and list of initial and final sensor data. Okay, having said that, let me quickly show you a demo of it. Now, let's click on the first example. So you see, these are the basketball players. So given images on the left hand side, and then the question is who are the two teams playing in this photo, and which was the last to win a championship, and which year did they win, and who was the star player that year. Let's think step by step. Now, with the help of vision, the model is able to produce this answer. It is saying team in white is New York Knicks, team in green is Boston Celtics, Last to win championship was Boston Celtics. Year was 2008. Star player was Paul Pierce. I'm not sure if this is correct. The question where you asked it, who was the star player after that? I'm not basketball and I just Google it. Amazing stuff. Now let's click the donut one. What flavor is the pink donut in the right? So write this one, and it is able on the right. Okay, for it one it is says on the left. What flavor is on the donut on the left? It says a blueberry. So this one is blueberry. Okay, let's click on one more. So it says a cow sitting on a rug. Why is the cow sitting on a rug? It's a joke because it wants to be a couch. Okay, well, that joke. Now it's saying a donkey is carrying a dog, cat, and rooster, and then it has produced. What do you call a donkey with a rooster on his back? A rooster booster. So it has created this joke. So you can see that not only this PaLM-E as has vision understanding, but also due to the power of large language model, it is able to generate text and do a lot of multimodal things. So pretty cool in my opinion. I think Google is really throwing it out of the park with different innovations here. So pretty exciting to see that. Anyway, I hope that you enjoyed it. If you have any thoughts, comments, please share them in the comments. And if you like the content, please consider subscribing to the channel. Thank you very much.